Welcome! Today we'll solve for the sine and cosine of double and half angles, given that cotangent theta equals -2 and secant theta is less than 0. Let's break this down step by step. First, let's determine which quadrant theta is in. Since secant theta is negative, and secant equals 1 over cosine, we know cosine theta must be negative. Additionally, cotangent theta equals -2, which means cosine theta over sine theta equals -2. Given these conditions, theta must be in quadrant 2, where cosine is negative and sine is positive. Now that we know cotangent theta equals -2, we can write that cosine theta over sine theta equals -2. Cross-multiplying, we get that cosine theta equals -2 times sine theta. We can use the Pythagorean identity, sine squared plus cosine squared equals 1, to solve for sine theta. Substituting our equation for cosine theta, we get sine squared plus 4 sine squared equals 1. Solving this, we get that sine theta equals plus or minus 1 over root 5. Since we know theta is in quadrant 2, sine theta must be positive. So sine theta equals 1 over root 5. Now, let's find sine of 2 theta and cosine of 2 theta using the double angle formulas. For sine of 2 theta, we use 2 sine theta cosine theta. For cosine of 2 theta, we use cosine squared minus sine squared. Substituting our values and simplifying, we get sine of 2 theta equals -4/5 and cosine of 2 theta equals -3/5. Finally, let's find sine and cosine of theta over 2 using the half angle formulas. For sine of theta over 2, we use plus or minus the square root of 1 minus cosine theta over 2. For cosine of theta over 2, we use plus or minus the square root of 1 plus cosine theta over 2. Substituting our value for cosine theta and considering the quadrant, we get sine of theta over 2 equals root 6 plus root 2 over 4, and cosine of theta over 2 equals -root 6 minus root 2 over 4. And that's how we solve for the sine and cosine of double and half angles using the given conditions. Remember to always consider the quadrant when determining sines of trigonometric functions.